The universe is an endless canvas of mysteries, a place where the ordinary rules of reality seem to bend and twist into the unimaginable. Out there, hidden in the vast darkness between stars, lie discoveries so strange they challenge everything we think we know. From planets that shouldn't exist to cosmic signals that defy explanation, the universe is full of enigmas waiting to unravel. And today, we're diving deep into the strangest ones ever found. Objects and phenomena so bizarre they'll make you question the very fabric of space and time. Picture this, a star that flickers unpredictably, dimming and brightening in ways science still can't fully explain. Or a planet so dark it absorbs nearly all light, a shadowy world lurking in the void. These aren't scenes from science fiction, they're real, documented wonders that astronomers have stumbled upon, each one more puzzling than the last. What if I told you there's a galaxy shaped like a giant question mark, as if the cosmos itself is teasing us with its secrets, or that somewhere out there, a mysterious radio signal repeats at precise intervals like a cosmic heartbeat with no known origin? These aren't just curiosities, they're clues, pieces of a puzzle that could rewrite our understanding of the universe. That's why we're here, because beyond the familiar glow of stars and planets, there's a hidden side of space, one filled with anomalies that defy logic, sparking debates among the brightest minds in science. Some of these discoveries might hold the keys to new physics, while others remain utterly inexplicable, leaving us in awe of just how much we don't know. So if you've ever looked up at the night sky and wondered what else is out there, you're in the right place. Strap in, because we're about to explore the 30 strangest things ever found in the universe, and by the end, you'll see the cosmos in a whole new light. The Boötes Void is one of the most unsettling mysteries in the cosmos, a sprawling abyss so vast it could swallow thousands of galaxies without a trace. Stretching an incomprehensible 330 million light-years across, this enormous region of space is almost completely empty, earning it the nickname the Great Nothing. To put that into perspective, if our Milky Way were placed inside it, our nearest galactic neighbor would be impossibly distant, leaving us isolated in an ocean of darkness. Scientists first stumbled upon this cosmic ghost town in the 1980s while mapping the universe, and its sheer emptiness defied all expectations. Most regions of space, even the emptiest, still have scattered galaxies or faint traces of matter. But the Boötes Void is different. Less than 1% of the galaxies it should contain are actually there. It's as if some unseen force reached in and scooped them out, leaving behind a vacuum so profound it challenges our understanding of how the universe structures itself. What could have caused such a bizarre void? One leading theory suggests it's the result of smaller voids merging over billions of years, like soap bubbles combining into one enormous cavity. Another, more unsettling idea proposes that something unknown, perhaps an advanced civilization or an exotic cosmic phenomenon, cleared out this region deliberately. But the most plausible explanation ties back to the early universe, where fluctuations in density may have left behind these vast empty pockets as space expanded. Yet, even with these theories, the Boötes Void remains an enigma. Its eerie silence taunts astronomers, making us wonder whether we're missing a fundamental piece of the cosmic puzzle. Could there be something hidden in that darkness, something we can't yet see? Or is this just one of nature's strange accidents, a reminder that the universe is far stranger than we ever imagined? Either way, the Great Nothing stands as a haunting testament to just how much we still have left to discover. Rising from the heart of our galaxy like two colossal ghosts, the Fermi Bubbles stretch 25,000 light-years into space, towering above and below the Milky Way's disk. Discovered in 2010 by NASA, a Fermi gamma-ray space telescope, these immense structures glow with high-energy gamma rays, forming a faint but unmistakable hourglass shape centered on our galaxy's core. For scale, if you could see them with the naked eye, they'd span half the night sky, monuments to some ancient cataclysmic event we're only beginning to decipher. What makes these bubbles so baffling isn't just their size, it's what's powering them. Gamma rays this intense usually point to unimaginably violent processes, and all evidence leads back to Sagittarius, a star, the supermassive black hole at the Milky Way center. One theory suggests that millions of years ago, Sagittarius, a star, devoured an enormous cloud of gas, releasing a titanic burst of energy that punched these bubbles into existence. Others propose a series of smaller eruptions or even a frenzy of star formation near the galactic center, but the truth is, no single explanation perfectly fits. Here's where it gets even stranger. The edges of the Fermi bubbles are razor-sharp, as if sculpted by some invisible force. Cosmic phenomena usually diffuse over time, fading into space like ink in water, yet these bubbles have maintained their crisp boundaries for millions of years. Some researchers speculate that powerful magnetic fields act like walls containing the energy within. Others wonder if dark matter plays a role, interacting in ways we don't yet understand. Then there's the eerie symmetry. The bubbles are nearly identical in size and shape, stretching the same distance north and south of the galaxy, a clue that whatever created them did so in a single, coordinated event. It's as if the Milky Way itself took a deep breath and exhaled two perfect plumes of energy into the void. Could this have been a quasar-like outburst, a black hole's temporary awakening? Or evidence of a galactic-scale process we've never witnessed before? Every answer seems to raise new questions, and that's what makes the Fermi bubbles so captivating. They're a cosmic fossil, a snapshot of our galaxy's violent past, and a reminder that even our home in the universe holds secrets we've only just begun to uncover. On the night of August 15, 1977, an astronomer named Jerry Amon was reviewing data from Ohio State University's Big Ear radio telescope when he saw something that would haunt him for the rest of his career. A signal so powerful, so anomalous, that he circled it in red ink and scribbled one word beside it: wow. This wasn't just any radio blip. Lasting 72 seconds, the signal blasted through the frequency band reserved for interstellar hydrogen, a natural choice for any civilization trying to announce its presence. It was 30 times stronger than the background noise of space, narrowly focused, and appeared to originate from the constellation Sagittarius, a region with no known stars or planets capable of producing such a transmission. Most chilling of all, it was never heard again. For decades, scientists have scrambled to explain the WOW signal's origins. Some suggest it could have been a comet, except no known comets were passing through that region of space at the time. Others propose military satellite interference or a rogue astrophysical event, but none match the signal's unique fingerprint, the most tantalizing theory. That it was a deliberate broadcast from an intelligent civilization, a cosmic hello that slipped through our fingers before we could reply. The enigma only deepens when you consider the signal's structure. Unlike natural cosmic noise, which tends to drift in frequency, the WOW signal held steady, just as you'd expect from a deliberately aimed transmission. And then there's the silence. Despite countless searches of the same patch of sky, not a single repeat has ever been detected. It's as if the universe handed us a one-time cipher and then swallowed the key. Could it have been a glitch, a fleeting quirk of our own technology? Possibly. But the Big Ear telescope was designed to filter out earthly interference, and no other artificial signals from that era match its profile. That leaves us with two unsettling possibilities. Either we witnessed an unprecedented cosmic fluke, or something, or someone, out there briefly turned their spotlight toward Earth. One thing's certain, the WOW signal remains astronomy's ultimate tease, a whisper from the void that defies explanation, taunting us with the possibility that we're not alone, and that the truth might still be waiting somewhere in the static between the stars. Deep in the silent expanse above our planet, an object drifts in the cold embrace of space, shrouded in mystery. wrapped in conspiracy and sparking debates that have raged for decades. They call it the Black Knight satellite, a name that evokes images of some ancient, otherworldly sentinel silently watching over Earth. Stories claim this enigmatic object has been orbiting our world for 13,000 years, a relic of an advanced alien civilization. But how much of this is science and how much is science fiction? The legend begins in the late 19th century, when inventor Nikola Tesla claimed to have intercepted strange radio signals he believed came from beyond Earth. Decades later, in the 1950s and 60s, both amateur radio operators and military tracking systems reportedly picked up unidentified echoes from orbit, something up there, reflecting signals back when no known human-made satellite should have existed. Then came the grainy photographs, one allegedly snapped during a 1998 space shuttle mission, showing a dark, irregular shape against the curve of Earth. Internet sleuths magnified every pixel, convinced this was proof of the Black Knight. But let's peel back the layers. NASA has repeatedly debunked the myth, explaining that many of these sightings were likely thermal blankets lost during spacewalks or fragments of defunct satellites, space junk caught in the light. The famous photograph, astronauts confirmed it was just a discarded insulation panel, tumbling harmlessly in orbit. Even the so-called ancient radio signals align with known natural phenomena like pulsars or atmospheric interference. Yet the mystery endures, and here's why. Some details don't neatly fit the official explanations. Early tracking data from the 1960s does show unexplained objects in polar orbit, a trajectory rarely used by human technology at the time. And why have multiple cultures, from the Sumerians to the Dogon people, described celestial watchers in their mythologies? Could these be coincidences or fragments of some long-lost truth? Then there's the strangest twist of all, the Black Knight's alleged orbit. Unlike most satellites which circle Earth's equator, this object purportedly moves in a near-perfect polar orbit, crisscrossing the poles in a precise, repeating path. If it were just space debris, wouldn't its trajectory decay or shift over time? Unless, of course, it wasn't debris at all. Skeptics argue the entire phenomenon is a textbook case of pattern-seeking human minds stitching together unrelated events into a compelling narrative. But believers counter with another question. In a universe as vast and ancient as ours, is it really so far-fetched to imagine we're not the first to cast a shadow across the stars? Whether the Black Knight is a modern myth or something more, one thing's certain: it's a reminder that even in our own cosmic backyard, the line between fact and folklore can blur in the most tantalizing ways. Among the swirling chaos of cosmic dust and gas, where most nebulae twist into organic, flame-like shapes, one structure stands out like a meticulously crafted artifact: the Red Rectangle Nebula. Located about 2,300 light-years from Earth in the constellation Monoceros, this bizarre formation resembles a glowing, geometric frame, its sides almost perfectly aligned into an eerie, box-like symmetry. Most nebulae are born from the explosive deaths of stars, forming chaotic clouds of debris. So how did this one end up looking like something drawn with a cosmic ruler? The answer might lie in the nebula's unusual origins. At its heart sits HD 44179, a dying star in the final stages of shedding its outer layers. But unlike other aging stars that eject material in all directions, HD 44179 is locked in a tight dance with an unseen companion, a second star whose gravity funnels the dying star's outflow into two opposing cones. As these twin jets collide with interstellar dust, they create the nebula's distinctive X-shape, while a thick disk of debris around the stars forces the structure into its sharp, rectangular edges. Its nature and geometry working in perfect, if unnatural, harmony. Then there's the color. The red rectangle owes its crimson glow to a class of organic molecules known as polycyclic aromatic hydrocarbons, complex carbon-based compounds rarely seen in such abundance. These molecules fluoresce under the star's ultraviolet light, painting the nebula in hues so vivid they've baffled scientists. Even stranger, spectral analysis suggests the presence of mysterious red emission bands, unidentified spectral lines that no known substance on Earth can explain. Some researchers speculate these could be signatures of entirely new forms of matter, forged in the extreme conditions around the dying star, but the real puzzle is the nebula's longevity. Most planetary nebulae dissipate within tens of thousands of years, their material scattering into the void. The red rectangle, however, has maintained its precise shape for millennia, defying the eroding forces of space. One theory suggests its dense central disk acts like a shield, sheltering the structure from interstellar winds. Another proposes that the binary star's unique orbit continually replenishes the nebula's form, like a fountain sculpting its own basin. What makes this cosmic oddity so captivating isn't just its beauty, it's the questions it forces us to confront. Are there other, equally precise structures hidden in the darkness? Could these hydrocarbon-rich nebulae be cosmic factories for the building blocks of life? And what unseen laws of physics might explain its unnerving symmetry? The red rectangle doesn't just defy expectations, it redraws them, reminding us that even in the vast, chaotic universe, order can emerge in the most unexpected ways. Imagine a world where mountains aren't made of rock, but of pure diamond, where the very ground beneath your feet would be the ultimate jewel. That's the reality of PSR J17191438b, a planet so dense and dazzling it defies the ordinary rules of cosmic geology. Discovered in 2011, orbiting a rapidly spinning pulsar 2,500 light-years from Earth, this exotic world isn't just sprinkled with diamonds, it's essentially one giant, crystallized carbon gem, forged in conditions so extreme they make the heart of a supernova seem tame. What makes this planet truly bizarre is its origin story. Most planets form from the leftover dust and gas swirling around young stars, but this one emerged from cosmic carnage. Its host, the pulsar PSR J17191438, was once a massive star that exploded in a supernova, leaving behind a hyperdense neutron star. The shockwave should have obliterated anything nearby, yet somehow a fragment of the star's companion survived. Scientists believe that companion was once a white dwarf, a dying star rich in carbon and oxygen. As the pulsar's gravity siphoned away its outer layers, the remaining core was crushed under unimaginable pressure, crystallizing into a planet-sized diamond roughly 5 times the mass of Earth packed into an object just half its width. Now here's where the mystery deepens. The pulsar's gravity is so intense that it whips this diamond planet around in a breakneck orbit lasting just 2 hours and 10 minutes, a year over before you could finish watching a movie. That proximity means the planet's surface endures constant bombardment from the pulsar's radiation, a deadly hail of high-energy particles that should have eroded it to nothing over millions of years. Yet it persists, enduring where no ordinary planet could. Some researchers speculate it's cloaked in an ultra-dense atmosphere of vaporized carbon, an invisible shield forged from the very material that makes up its core. But the real puzzle is the diamond itself. On Earth, diamonds form deep underground where pressure squeezes carbon atoms into crystalline structures. On PSR J17191438b, the pressure is millions of times greater, creating a form of crystallized carbon so dense it might behave more like a metal than a gem. Could this substance conduct electricity? Could it even be a new state of matter? No one knows for sure because recreating such conditions in a lab is impossible with current technology. Then there's the haunting question no scientist can fully answer: how many more of these cosmic jewels are out there? If one survived the violent death of a star, could others lurk in the debris of ancient supernova? The diamond planet isn't just a celestial curiosity. It's a glimpse into a universe far stranger than we ever imagined, where the line between science and myth blurs in the most breathtaking ways. In the vast silence of space, where most signals fade into the cosmic background, there are flashes so brief and powerful they outshine entire galaxies for less than the blink of an eye. These are fast radio bursts, or FRBs, some of the most enigmatic phenomena in the universe. Lasting mere milliseconds, each burst packs the energy of 500 million suns, vanishing before we can fully trace their origins. What could possibly unleash such violent, fleeting eruptions across the cosmos? The answer might rewrite our understanding of physics itself. The first FRB was detected in 2007, buried in archival data from Australia's Parkes Observatory. Since then, hundreds more have been recorded, each one a transient scream of radio waves slicing through the darkness. But one stands out from the rest: FRB 121102, the first repeating fast radio burst ever discovered. Unlike its one-off counterparts, this source, located 3 billion light-years away in a dwarf galaxy, has fired off multiple bursts since 2016, sometimes in frantic clusters, other times with eerie regularity. It's as if something or someone is flicking a cosmic switch on and off, teasing us with a pattern we can't yet decipher. So what's causing these bizarre signals? One leading theory points to magnetars, ultra-dense, highly magnetized neutron stars spinning at dizzying speeds. When their crusts crack under intense magnetic stress, they could release apocalyptic quakes, sending shockwaves rippling through space as radio bursts. In 2020, astronomers even caught a magnetar in our own galaxy emitting an FRB-like pulse, lending weight to the idea. But there's a problem. Most magnetar bursts are far weaker than the colossal FRBs from deep space. Could there be a more extreme version of these stars, or are we missing a piece of the puzzle? Then there's the darker, more speculative possibility. Could FRBs be artificial? The burst's intensity and precision have led some scientists to ponder whether they might be signatures of advanced technology. Perhaps alien propulsion systems harnessing unimaginable power, or beacons meant to announce a civilization's presence. The repeating nature of FRB 121102 only fuels these questions. Why would a natural phenomenon follow such a rhythm? Yet the most compelling clues might lie in the burst structure. Recent studies reveal that some FRBs exhibit scattering, a telltale distortion caused by passing through dense magnetic fields. This suggests they originate in extreme environments, like the turbulent regions near supermassive black holes or the fiery aftermath of colliding stars. Even stranger, some bursts arrive with a sad trombone effect, their frequencies sliding downward in a cosmic glissando, a hint that the source might be moving at staggering speeds through turbulent space. Every new detection deepens the mystery. In 2022, astronomers traced another repeating FRB to a globular cluster, an ancient swarm of stars where magnetars shouldn't exist. Then there's FRB 20190520b, a burst so close, just 700 million light-years away, that its host galaxy can be studied in stunning detail, yet its origin remains frustratingly unclear. The truth is, FRBs challenge everything we know about cosmic energy. They're too brief to predict, too powerful to explain, and too widespread to ignore. Whether they're the death throes of exotic stars, the echoes of interstellar collisions, or something far stranger, one thing's certain: these millisecond marvels are forcing us to rethink the limits of the possible. And with every new burst, the universe whispers another clue. If only we could listen fast enough. There's something unsettling happening at the edge of everything we know, a cosmic current pulling thousands of galaxies in the same direction, as if the universe itself is being tugged toward something we can't see. Astronomers call it the dark flow, and it's one of the most perplexing discoveries in modern cosmology. Imagine a river flowing through space, but instead of water, It's entire clusters of galaxies, some containing thousands of stellar systems, all drifting toward a single point beyond the observable horizon. This isn't just random motion. It's a coordinated movement so vast and so inexplicable that it challenges our most fundamental understanding of how the universe works. The dark flow was first detected in 2008 when scientists studying microwave radiation from the early universe noticed something strange. Galaxy clusters weren't just moving apart due to cosmic expansion. They were also streaming in a uniform direction at speeds exceeding 600 miles per second. What made this so bizarre is that, according to the Big Bang's afterglow, matter should be distributed evenly with no preferred direction. Yet here was evidence of a colossal drift, like leaves caught in a wind blowing from a place we can't observe. Even more unsettling, the pull seems to originate from a void, a region of space so far away that its light hasn't had time to reach us in the 13.8 billion years since the universe began. So what could be causing this? One theory points to gravitational anomalies, massive structures lurking beyond the cosmic horizon, so enormous their gravity warps spacetime across unimaginable distances. These could be superclusters of galaxies on a scale we've never seen, or even exotic objects like cosmic strings, hypothetical defects in spacetime left over from the universe's birth. But there's a catch. The dark flow's alignment is too precise, too uniform for conventional explanations. The sheer scale of force required suggests something far stranger might be at play. That's where the multiverse hypothesis comes in. Some physicists speculate the dark flow could be evidence of a neighboring universe, a parallel cosmos brushing against our own, its gravity leaking through the fabric of reality. In this scenario, our universe isn't floating alone in nothingness. It's part of an infinite ocean of other universes, each with its own physics, its own dimensions. The dark flow might be our first glimpse of that greater reality, a signpost pointing to realms beyond our comprehension. Critics argue the data could be an illusion, a quirk of measurement, or an artifact of how we map cosmic microwave background radiation. But as technology improves, the evidence only grows stronger. New studies confirm the flow extends even farther than initially thought, affecting galaxy clusters over billions of light years. If this is real, the implications are staggering. It would mean there's more to the cosmos than we ever dreamed, vast, unseen structures or even entire universes exerting their influence on ours. The dark flow is more than a scientific curiosity. It's a cosmic riddle that forces us to confront how little we truly understand. Are we being pulled toward something, or is the universe whispering that its boundaries are far wider, far stranger than we ever imagined? Until we peer beyond the horizon, this mysterious current will remain one of space's greatest unsolved puzzles, a silent river flowing toward the unknown. Among the countless stars in the Milky Way, one burns with a mystery so deep it sparked a scientific firestorm, KIC 8462852, better known as Tabby's star. Named after astronomer Tabitha Boyajian, who led the team that first documented its bizarre behavior, this unassuming flicker of light in the constellation Cygnus does something no other star should. It dims erratically, dramatically, as if something colossal is passing in front of it. Not by a predictable 1 or 2% like a planet would cause, but by staggering 22% at times, a fluctuation so extreme it defies every conventional explanation. The first clues came from NASA's Kepler Space Telescope, which observed the star between 2009 and 2013. While most stars showed gentle, rhythmic dips in brightness from orbiting planets, Tabby's star dropped in irregular, jagged patterns, sometimes for days, other times for weeks, with no discernible rhythm. Then came the real shocker. Historical data revealed the star's overall light had faded by a staggering 14% over the past century. Stars don't just dim like this. Not naturally, anyway. Cue the alien megastructure hypothesis. In 2015, astronomer Jason Wright proposed an electrifying idea. What if the dimming was caused by a Dyson swarm, a vast array of energy-collecting panels built by an advanced civilization? The concept, first imagined by physicist Freeman Dyson, suggests a society so advanced it could harness its star's power by surrounding it with orbiting megastructures. The irregular dips may be construction projects or vast solar panels shifting in orbit. Suddenly, Tabby's star wasn't just an anomaly. It was a potential beacon of extraterrestrial intelligence, and the world took notice. But science thrives on skepticism. Subsequent studies searched for technosignatures, radio signals, laser pulses, any trace of artificial activity. None were found. Alternative explanations emerged, perhaps swarms of comets, shattered planets, or dense clouds of interstellar dust were to blame. By 2018, new data pointed to microscopic dust particles as the likely culprit, scattering light unevenly as they orbited the star. Except there's a catch: this dust behaves unlike any seen before. It's too fine, too uneven, and it doesn't emit the infrared heat such debris usually would. The mystery only deepens when you consider the star's sporadic brightening episodes, moments when it inexplicably grows brighter before dimming again. Dust alone can't fully explain these surges. Some researchers speculate the star might be consuming a planet, its violent digestion casting irregular shadows. Others wonder if it's surrounded by a warped, asymmetrical ring system unlike anything in our solar system. Then there's the haunting possibility that we're seeing the aftermath of a colossal collision. Two planets smashing together, their debris still swirling in the chaos. What makes Tabby's star so compelling isn't just the unanswered questions. It's the way it forces us to confront the limits of our knowledge. Here's an object that defies categorization, resisting every tidy explanation thrown at it. Even now, telescopes keep watch because the next dimming event could hold the key. Whether it's dust, debris, or something beyond our current understanding, one thing's certain: this star refuses to be ordinary. And in that refusal, it reminds us that the universe always has another puzzle waiting, one that might, just might, rewrite the story of how we see the cosmos. Hidden behind the thick veil of stars and dust near the heart of our own galaxy, something massive is pulling thousands of galaxies toward it, including our own Milky Way. Astronomers call it the Great Attractor, a gravitational anomaly so powerful it warps the motion of entire galaxy clusters across hundreds of millions of light years. Picture a cosmic whirlpool, its current dragging everything nearby into its unseen depths. The strangest part, we can't even see it directly. This colossal mystery lies in what scientists call the zone of avoidance, an area of the sky obscured by the dense disk of the Milky Way, where our galaxy's own stars, gas, and dust block our view of the universe beyond. For decades, astronomers trying to study this region hit an observational wall, like trying to peer through a fogged-up window. But thanks to infrared and radio telescopes that cut through the cosmic clutter, we've begun to map the invisible. What they've found is staggering: an immense concentration of mass, roughly equivalent to tens of thousands of Milky Ways, exerting a gravitational pull so strong it overrides the expansion of the universe itself in our local cosmic neighborhood. So what exactly is the Great Attractor? One leading theory points to the Norma Cluster, a dense gathering of galaxies about 250 million light-years away. But here's the catch: the Norma Cluster alone doesn't have enough mass to explain the observed pull. That means the Great Attractor might just be the visible tip of something far larger, perhaps a supercluster of galaxies we're only beginning to trace. Some researchers speculate it's part of an even more enormous structure called Laniakea, a galactic filament spanning 500 million light-years with the Great Attractor at its heart. But the intrigue doesn't stop there. Recent studies suggest the Great Attractor itself may be moving, dragged toward something even more massive lurking beyond. Dubbed the Shapley supercluster, the largest known concentration of matter in the observable universe. It's as if we're caught in a cosmic tug of war between unseen giants, with our galaxy caught in the middle. What does this mean for us? Over billions of years, the Milky Way and our neighboring Andromeda galaxy, along with dozens of smaller galaxies in our local group, are all being reeled in by this invisible force. But don't worry, this isn't a doomed journey into a black hole's maw. The Great Attractor isn't a single dense object, but rather a diffuse concentration of mass, meaning we'll likely merge with other galaxies in its vicinity long before reaching its core. Still, its existence forces us to confront a humbling truth. Even as we map the cosmos, some of its grandest structures remain hidden in plain sight, shaping our fate from the shadows. The race to understand the Great Attractor isn't just about solving a gravitational puzzle, it's about rewriting the map of our universe. Every new observation peels back another layer of the zone of avoidance, revealing more about the forces that bind the cosmos together. And with each discovery, we're reminded that sometimes the most powerful influences are the ones we can't even see. Among the countless galaxies strewn across the cosmos, one stands apart not for its size or brightness, but for its eerie, almost artificial symmetry. Hoag's object, discovered in 1950 by astronomer Arthur Hoag, is a ring galaxy so perfectly circular it looks like someone drew it with a cosmic compass. Floating 300 million light-years away in the constellation Serpens, this celestial oddity consists of a luminous golden core surrounded by a pristine blue ring of young stars, separated by a dark gap so clean it could have been etched with a scalpel. Most galaxies evolve through violent collisions or slow mergers, their shapes twisting into spirals or blobs over billions of years. But Hoag's object defies all of that, presenting a puzzle that challenges our understanding of how galaxies form. What makes this structure so baffling is the gap between its core and ring, an empty void spanning tens of thousands of light-years. Typically, ring galaxies form when a smaller galaxy punches through the center of a larger one, sending shockwaves through its disk that trigger star formation in a circular ripple. But Hoag's object shows no signs of such a collision. There's no debris, no distortion in its core, no secondary galaxy lurking nearby to blame. It's as if the ring simply decided to form on its own, leaving astronomers scrambling for alternative explanations. One theory suggests a rare resonance effect, gravitational forces aligning gas clouds into a perfect circle as the galaxy rotates. Another posits that an ancient, unstable core ejected its outer layers in a symmetrical burst, leaving behind a ring of star-forming material. Then there's the more speculative idea that we're seeing the aftermath of an extreme bar instability, where a galaxy's central bar of stars dissolved, flinging material outward in a near-perfect loop. But none of these theories fully account for the object's flawless geometry or the absence of a visible trigger. Adding to the enigma is the ring itself. Spectroscopic analysis reveals it's brimming with newborn stars, their blue light contrasting sharply with the older, yellower stars of the core. Stranger still, the ring isn't just a single structure, it's laced with intricate knots and filaments, suggesting multiple waves of star formation occurring at different times. How does a galaxy sustain such a delicate balance, nurturing new stars in its outer ring while its center remains static? Perhaps the most tantalizing clue lies in what's not there. In 2021, astronomers discovered a second, fainter ring surrounding the galaxy, a ghostly echo of the first, hinting at an even older, larger structure that faded eons ago. This suggests Hoag's object might be the product of multiple, layered events, each leaving behind a ripple in the galactic pond. But without evidence of past collisions or mergers, the mechanism remains elusive. Even more peculiar, peering deeper into the void around Hoag's object, researchers spotted another ring galaxy floating almost perfectly aligned behind it, an unrelated cosmic doppelganger. The odds of two such rare objects lining up from our vantage point are astronomically slim, as if the universe is playing a visual trick to underscore just how little we understand about these perfect celestial circles. Hoag's object isn't just a galactic oddity, it's a cosmic question mark challenging us to rethink how structure emerges in the universe. Whether it's the product of a forgotten cataclysm or some undiscovered quirk of physics, one thing's certain. In a cosmos dominated by chaos, this galaxy's quiet perfection is its greatest rebellion. And until we unravel its secrets, it will continue to float in the darkness, a silent reminder that even the simplest shapes can hold the deepest mysteries. Picture a structure so vast it defies comprehension, a sprawling, thread-like network of galaxies stretching an unimaginable 10 billion light-years across the cosmos. This is the Hercules Corona Borealis Great Wall, the largest known arrangement of matter in the observable universe. Discovered in 2013 by mapping gamma-ray bursts the fleeting death cries of massive stars. This cosmic behemoth shouldn't exist. At least not according to the foundational principles of modern cosmology. The wall's sheer scale is enough to stagger the mind. To put it in perspective, if you could travel at the speed of light, it would take you 10 billion years to cross from one end to the other, more than half the age of the universe itself. Within this unfathomable expanse, hundreds of thousands of galaxies cluster along faint filaments, woven together by gravity like beads on an invisible string. But here's the problem. According to the cosmological principle, the universe should look roughly the same in all directions on large scales. No glaring irregularities, no structures this immense. The Hercules Corona Borealis Great Wall doesn't just bend that rule, it shatters it. So how did something this colossal come to be? One theory suggests it's a fossil from the universe's infancy, a relic of primordial density fluctuations that somehow survived expansion. In the first moments after the Big Bang, microscopic quantum ripples in spacetime may have seeded regions where matter clumped more densely. Over billions of years, gravity amplified these wrinkles, sculpting them into the vast walls and voids we see today. But even this explanation falls short. The Great Wall is too big, too coherent, as if the universe's initial conditions conspired to create a structure beyond natural limits. Then there's the unsettling possibility that our understanding of the universe's evolution is incomplete. Could dark energy, the mysterious force accelerating cosmic expansion, have behaved differently in the past? Might there be exotic physics at play, warping spacetime on scales we've only begun to glimpse? The wall's existence forces us to confront these questions, hinting that the cosmos might be far stranger and far less uniform than we ever imagined. Adding to the mystery is the wall's shadowy nature. Unlike galaxy clusters or nebulae, we can't see it directly. Its outline was traced by the gamma-ray bursts of dying stars, ephemeral flashes that act like cosmic breadcrumbs, marking the densest regions of matter. But even this method has limits. What if the structure extends beyond what we've mapped? Some researchers speculate the wall could be part of an even grander pattern, a fractal-like arrangement repeating across deeper layers of the universe. The Hercules Corona Borealis Great Wall isn't just an astronomical curiosity, it's a challenge to our very understanding of reality. If such titanic structures exist, what else lies hidden in the darkness? And what does it mean for the future of cosmology when the universe's largest known object refuses to play by the rules? Every new observation peels back another layer of this enigma, reminding us that the cosmos still holds wonders beyond our wildest theories. In 1572, Danish astronomer Tycho Brahe looked up at the night sky and saw something impossible, a new star blazing brighter than Venus where no star had been before. This was no ordinary celestial event. It was a supernova, the violent death of a star so powerful it outshone entire galaxies for weeks. But 400 years later, astronomers studying the remnants of Tycho's supernova found something even more shocking. The star wasn't completely dead. Against all odds, this cosmic corpse had briefly flickered back to life, earning it the nickname the zombie star. Tycho's supernova belongs to a special class known as Type Ia, the universe's standard candles. These explosions occur when a white dwarf, the dense, Earth-sized core of a dead star, siphons enough material from a companion to cross a critical threshold, triggering a runaway thermonuclear explosion. The blast is so uniform that astronomers use these events to measure cosmic distances. But Tycho's supernova didn't follow the script. When researchers examined its remnant with modern telescopes, they discovered patches of hydrogen, an element that shouldn't be there. Type Ia supernova was supposed to be hydrogen-free, the clean detonations of pure carbon and oxygen. So where did this rogue gas come from? The answer might rewrite astrophysics textbooks. One leading theory suggests the white dwarf wasn't stealing material from a typical companion star, but from a hydrogen-rich gas cloud, contaminating its explosion with unexpected elements. Others propose an even wilder scenario, that the star survived its first explosion, lingering as a half-dead ember before reigniting years later. Imagine a firework that fizzles out, only to explode again with twice the force. That's what makes this zombie star so unnerving. It challenges our understanding of stellar deaths, proving that even in the grave, stars can still surprise us. Adding to the mystery are strange features in the supernova remnant itself. High-resolution X-ray images reveal a lopsided debris field, as if the explosion fired off more material in one direction than the other. Some researchers speculate the white dwarf might have spun so fast it distorted the blast, like a wobbly top losing balance. Others wonder if the companion star's gravity warped the explosion, funneling debris into bizarre shapes. Whatever the cause, one thing's clear: this wasn't the textbook supernova scientists thought they knew. Perhaps the most haunting question is whether Tycho's star is unique, or if others like it lurk in the darkness. Could there be more zombie stars out there, masquerading as ordinary supernova while hiding their true nature? Every new observation peels back another layer of this cosmic enigma, reminding us that even the most studied phenomena can harbor secrets. The universe doesn't play by our rules, and sometimes, just when we think we've seen it all, the dead rise again to teach us something new. Deep in the heart of the Virgo cluster, a cosmic predator lurks: Messier 87, a supergiant galaxy with an appetite so voracious it has consumed entire stellar systems over billions of years. This isn't just any galaxy, it's a celestial titan stretching over 120,000 light-years and harboring secrets that rewrite the rules of astrophysics. At its core lies an unfathomable beast, the first black hole ever photographed, a gravitational monster weighing in at 6.5 billion times the mass of our Sun. But what makes M87 truly terrifying isn't just what it contains, it's what it's done to get there. Galactic cannibalism isn't just a metaphor here. M87's history is written in the corpses of smaller galaxies it has torn apart and absorbed. Like a spider sitting at the center of a web, its immense gravity pulls in passing galaxies, stretching them into stellar streams before swallowing them whole. Astronomers call this hierarchical merging, the idea that galaxies grow by devouring their neighbors, and M87 is the universe's most ruthless example. Traces of its meals can still be seen in rogue star clusters orbiting its outskirts, the cosmic equivalent of bones scattered around a predator's den. Then there's the jet, spewing from the black hole's poles at nearly the speed of light. A 5,000 light-year-long beam of superheated plasma pierces the darkness like a cosmic blowtorch. This isn't just random chaos, it's a precision-engineered death ray powered by the black hole's insatiable spin. As matter spirals toward oblivion, magnetic fields funnel some of it away, launching it into space in a collimated beam so powerful it glows in radio waves across the universe. Imagine a hurricane channeled into a laser. That's the level of controlled violence we're talking about. What makes this jet even more astonishing is its stability. Unlike the messy eruptions seen in younger galaxies, M87's jet has likely been firing for millions of years, its path unwavering. Some researchers believe the black hole's spin acts like a gyroscope, keeping the jet locked on target across geologic timescales. Others speculate that the surrounding gas left over from digested galaxies feeds the beam like fuel to a fire, ensuring it never falters. Either way, it's a stark reminder that this galaxy doesn't just dominate its corner of the cosmos, it sculpts it. But the real revelation came in 2019, when the Event Horizon Telescope unveiled humanity's first glimpse of M87's black hole shadow. That now iconic orange ring glowing against the darkness wasn't just a scientific triumph, it was a window into the engine driving this galactic juggernaut. The image confirmed Einstein's predictions with eerie precision, showing light bent into a perfect circle by gravity so intense even photons can't escape. Yet it also raised new questions. Why is the ring asymmetrical? Could there be hidden structures warping space-time near the event horizon? And most hauntingly, how many more galaxies has this black hole consumed to grow so large? M87 isn't just a relic of the past, it's a harbinger of our own future. In about 5 billion years, the Milky Way will collide with Andromeda, potentially birthing a similar supergiant galaxy. Will our descendants gaze up at a sky dominated by a single, ravenous black hole, its jets carving paths through the night? Messier 87 offers a chilling preview, a reminder that in the grand cosmic dance, even galaxies aren't safe from being eaten alive. And as we study its secrets, we're left to wonder, in a universe where giants like this exist, what else is lurking in the shadows waiting to be found? Floating in the afterglow of the Big Bang, there's a patch of sky that shouldn't exist, a chilling void in the cosmic microwave background radiation known simply as the cold spot. Stretching nearly 2 billion light-years across, this eerie region is significantly colder than its surroundings, defying the otherwise smooth temperature distribution of the early universe. Discovered in 2004 by NASA, a Wilkinson microwave anisotropy probe, this anomaly isn't just a statistical fluke. It's a cosmic glitch so profound that some scientists believe it could be evidence of another universe brushing against our own. At first glance, the cold spot seems like a flaw in the data. After all, the cosmic microwave background is the oldest light in existence, a snapshot of the universe just 380,000 years after the Big Bang. It should be almost perfectly uniform, with tiny temperature fluctuations reflecting the seeds of future galaxies. But the cold spot is different. Its temperature drops by about 70 microkelvin, a discrepancy far larger than standard cosmology can easily explain. So what could have left this frozen fingerprint on the fabric of spacetime? One leading theory points to a supervoid, an enormous, nearly empty region of space where the lack of matter causes light to lose energy as it travels through, an effect known as the integrated Sachs-Wolf effect. If such a void exists, it would stretch over 1 billion light-years, making it the largest known structure in the universe. The problem: surveys of the cold spot's vicinity haven't found enough galaxies missing to account for its staggering chill. It's as if we're staring at a shadow cast by something invisible, a cosmic blank space where the rules of physics don't quite apply. That's where things get truly bizarre. Another explanation, far more radical, suggests the cold spot might be a bruise, a collision between our universe and a parallel one during the chaotic moments of cosmic inflation. According to this hypothesis, the multiverse isn't just a theoretical abstraction but a tangible reality, with countless bubble universes existing alongside ours. If one of those bubbles bumped into ours in the distant past, the energy of that impact could have left behind a scar, a region where the background radiation cooled anomalously. It's a wild idea, but one that's gained traction among physicists searching for evidence beyond our cosmological horizon. Skeptics, of course, argue the cold spot is nothing more than a statistical anomaly, a rare but inevitable fluctuation in an otherwise orderly cosmic tapestry. They point to the sheer size of the observable universe, where even the most improbable events can occur by chance alone. Yet the cold spot refuses to fit neatly into this narrative. Detailed studies show its structure is subtly layered, with smaller cold rings nested inside the larger one, a pattern that doesn't align with random noise. Whether it's a cosmic accident, a gaping void, or a window into the multiverse, the cold spot forces us to confront the limits of our understanding. It's a reminder that even the most refined models of the universe can't account for every anomaly, and that some mysteries might require us to rewrite the rules entirely. As telescopes grow more powerful and simulations more precise, we may one day uncover the truth behind this frozen enigma. Until then, it lingers in the data, a silent challenge to everything we think we know about reality. Nestled in the constellation Libra, a faint yellow glow pulses with a secret that has astronomers questioning the very timeline of the cosmos. This is HD 140283. Better known as the Methuselah star, a celestial elder so ancient its estimated age once surpassed that of the universe itself. At first glance, it seems impossible. How can a star be older than the space it inhabits? This paradoxical discovery sent shockwaves through the scientific community, forcing us to reconsider everything we thought we knew about stellar lifespans and cosmic origins. Precision dating techniques place Methuselah's age at approximately 14.5 billion years, give or take 800 million. That's a problem because the universe itself is only 13.8 billion years old. It's like finding a 500-year-old manuscript inside a 400-year-old library, an inconsistency so glaring it demands explanation. Scientists first noticed the discrepancy when analyzing the star's composition. Unlike younger stars rich in heavier elements, Methuselah contains almost no iron, a telltale sign it formed from the pristine gas of the early universe before generations of supernova could seed the cosmos with metals. So how did this cosmic conundrum arise? One key lies in the margin of error. Stellar age estimates rely on complex models factoring in brightness, distance, and chemical makeup. Early calculations didn't account for subtle effects like oxygen abundance, which we now know can skew results. Revised models incorporating these factors brought Methuselah's age down to roughly 13.7 billion years, still ancient but no longer breaking the cosmic rulebook. Yet even this adjustment doesn't fully resolve the puzzle. The star's extreme age pushes the boundaries of stellar formation, suggesting the first stars ignited sooner after the Big Bang than previously believed. Here's where things get fascinating. Methuselah isn't just old, it's a rare population 2 star belonging to the second generation of stars ever born. Its composition acts as a cosmic time capsule, preserving the chemistry of the infant universe. Unlike primordial population 3 stars, which have never been observed but are theorized to be massive and short-lived, Methuselah formed from material enriched by those first stars' explosive deaths. Its survival challenges our understanding of stellar longevity. Most stars this metal poor should have burned out eons ago, yet Methuselah persists as a fragile subgiant, teetering on the edge of exhausting its hydrogen fuel. The implications ripple across cosmology. If stars could form so quickly after the Big Bang, the early universe might have been more dynamic than we imagined. Some theorists propose tweaks to the Hubble constant, the rate of universal expansion, to reconcile stellar and cosmic ages. Others suggest dark energy's influence may have altered the universe's expansion history in ways we don't yet grasp. Then there's the radical notion that our universe inherited pockets of pre-existing matter from a prior cosmic cycle, though this remains speculative. Peering at Methuselah is like staring into a cosmic mirror reflecting our own ignorance. Its flickering light carries whispers from an era before galaxies fully formed, before planets coalesced, when the universe was a blank canvas awaiting its first brushstrokes. Every new observation peels back another layer of mystery, reminding us that even the oldest stars still have stories left to tell. And as we refine our telescopes and models, we might yet discover that the answer to this age paradox reveals not an error in our calculations, but a deeper truth about time itself. Imagine a moon so massive it dwarfs every planet in our solar system, a world where a single sunset might stretch for weeks over an endless horizon of swirling gas. That's the tantalizing possibility of Kepler-1625b, the first credible candidate for an exomoon ever discovered, orbiting a gas giant 8,000 light-years away. This isn't just another footnote in astronomy, it's a glimpse into an entirely new class of worlds, one that could redefine how we think about moons, planets, and the delicate dance between them. The story begins with NASA's Kepler Space Telescope, which detected subtle dimming patterns around the planet Kepler-1625b, a Jupiter-sized world circling its star every 287 days. But something was off. The planet's transits weren't perfectly symmetrical. Just before the main dip in starlight, there was a smaller, secondary dimming, as if something huge, was trailing the planet like a cosmic shadow. When researchers analyzed the data, the numbers pointed to an unthinkable conclusion: a Neptune-sized moon nearly 4 times Earth's diameter, tethered to its host by gravity's invisible thread. Here's why that's revolutionary. Moons this large shouldn't exist under current formation models. In our solar system, the largest moon, Jupiter's Ganymede, is just 2% the size of its host planet. Kepler-1625b, by contrast, is a staggering 1.5% the mass of its planet, blurring the line between moon and binary planet. How could such a behemoth form? One theory suggests it's a captured rogue planet, snatched by the gas giant's gravity during the system's chaotic youth. Another posits it was born from a titanic collision, much like Earth's moon, but on a scale so vast it defies imagination. But confirming this moon's existence has been a nightmare of cosmic proportions. Exomoons are notoriously hard to spot. Their signals drown in the glare of their host stars and the noise of interstellar space. Even the Hubble Space Telescope, which followed up on Kepler's findings, could only provide tentative support. The data showed tantalizing hints: a slight timing wobble in the planet's orbit, consistent with a massive moon's gravitational tug, but not the smoking gun astronomers craved. Critics argue the signal could be stellar activity masquerading as a moon, or artifacts in the data processing pipeline. The stakes couldn't be higher. If real, Kepler-1625b opens a window into exotic lunar systems where moons rival planets in size and complexity. Imagine atmospheres thick with hydrogen and helium, oceans of superfluid methane, or even, in the right conditions, the faint whisper of a magnetic field. This wouldn't just be a moon, it would be a world in its own right, a place where the very definition of habitability might need rethinking. Yet for all its promise, the candidate remains just that, a candidate. Future telescopes like the James Webb Space Telescope could settle the debate, scrutinizing the system for chemical signatures or atmospheric clues. Until then, this phantom moon lingers at the edge of confirmation, a reminder of how much we still have to learn about the celestial choreography unfolding beyond our solar system. Whether it's a statistical mirage or the first of many giant moons waiting to be discovered, one thing's certain: the universe loves to surprise us, often in ways we're barely equipped to see. Star Trek fans might recognize the galactic barrier, a shimmering, purple energy field at the edge of the Milky Way that drove starships mad and unleashed psychic powers in the crew. While that's pure science fiction, astronomers have stumbled upon something almost as bizarre lurking in the real cosmos: vast, invisible boundaries that could make interstellar travel far more treacherous than we ever imagined. Take the Fermi Bubbles, for example, those colossal gamma-ray structures towering above our galaxy. Their edges are so sharp they resemble a force field, containing high-energy particles with an efficiency that defies natural diffusion. Or consider the heliosphere, the magnetic bubble created by our sun's solar wind, which shields the solar system from deadly cosmic rays. Venture beyond it, and you'd face an interstellar medium 4 times hotter and denser than expected, a wall of searing plasma that could fry unprotected electronics. Then there's the real showstopper, the Milky Way's own magnetic fields. Our galaxy is laced with invisible filaments of magnetism, some stretching tens of thousands of light years, woven through the interstellar medium like a colossal spiderweb. These fields aren't just subtle ripples, they're powerful enough to deflect charged particles, trap cosmic rays, and even influence how stars form. For any future spacecraft propelled by solar sails or ion drives, navigating these tangled magnetic highways could be like sailing through a minefield blindfolded. But the most daunting barrier might be one we can't even see. Dark matter, that enigmatic substance making up 27% of the universe, is thought to form vast halos around galaxies. While it doesn't interact with light, its gravitational pull could warp spacetime in ways we don't yet understand, creating hidden turbulence or gravitational riptides far from any star. Imagine setting off into the void, only to find your ship caught in an invisible current no one mapped. Of course, none of these obstacles glow purple or induce psychic hallucinations, sorry, Star Trek enthusiasts. But they pose challenges just as formidable. Whether it's magnetic chaos, radiation storms, or the unseen grip of dark matter, the galaxy seems determined to remind us space isn't just empty. It's a labyrinth of forces we're only beginning to decipher. And for now, the greatest barrier to interstellar travel might not be distance but the universe itself, quietly guarding its frontiers with laws we're still learning to navigate. Sailing silently through the solar system in 2017, an object from the void beyond our stars ignited one of the most heated debates in modern astronomy. Oumuamua, Hawaiian for Scout, was the first confirmed interstellar visitor ever detected, a traveler from another star system passing through our cosmic neighborhood. But this wasn't just any space rock. From the moment telescopes locked onto its faint silhouette, Oumuamua defied every expectation, displaying behavior so bizarre that even seasoned scientists struggled to explain it. First, there was its shape. Most asteroids and comets are roughly spherical or lumpy, shaped by gravity and collisions over billions of years. Oumuamua, though, appeared elongated, possibly 10 times longer than it was wide, like a cosmic cigar tumbling end over end. Some estimates suggested an even more extreme profile, resembling a flattened pancake. This bizarre geometry made it reflect sunlight in unpredictable ways, its brightness flickering wildly as it spun. Then came the real shocker. As it hurtled away from the sun, Oumuamua accelerated slightly, as if pushed by an unseen force. Comets often exhibit similar boosts when their ices vaporize, forming tails that act like natural thrusters, but Oumuamua showed no visible outgassing, no dusty coma, nothing to explain the extra kick. Theories erupted like supernova. One camp argued it was a rare hydrogen iceberg, a chunk of frozen molecular hydrogen slowly vaporizing in sunlight, leaving no visible trace. The problem: such objects have never been observed, and most models suggest they'd evaporate long before reaching interstellar space. Another explanation posited a nitrogen ice fragment, sheared off a Pluto-like exoplanet billions of years ago. But again, the numbers didn't quite add up. The required nitrogen abundance stretches plausibility. Then, of course, there was the most provocative idea: Oumuamua could be artificial. Harvard astrophysicist Avi Loeb famously suggested it might be a light sail, a thin, reflective structure propelled by solar radiation, perhaps of extraterrestrial origin. The scientific community bristled, but the hypothesis underscored how thoroughly this object upended our assumptions. Here's where the mystery deepens. In 2019, astronomers discovered a second interstellar visitor, 2I Borisov, a textbook comet with a fuzzy tail and familiar behavior. Unlike Oumuamua, Borisov fit neatly into existing frameworks, making its predecessor seem even more anomalous. Was Oumuamua a statistical fluke or a signpost pointing to phenomena we've yet to categorize? The longer we ponder its secrets, the clearer it becomes. This wasn't just a visitor from another star system. It was a messenger reminding us that the universe is far stranger, far more inventive than our textbooks dare to suggest. And the next time an interstellar wanderer appears, we'll be watching, ready to decode whatever riddles it brings. Imagine a galaxy where the night never ends, where stars are so few and far between that darkness reigns supreme. These are the ghost galaxies of the cosmos, vast islands of matter drifting through the void with almost no stars to light their way. Unlike the Milky Way's spiraling arms or Andromeda's glittering disk, these shadowy structures are made almost entirely of dark matter, the invisible glue holding the universe together. Detecting them is like trying to spot a whisper in a hurricane, yet their existence challenges our understanding of how galaxies form and why some fail to ignite. The first hints of these cosmic phantoms emerged in the early 2000s when astronomers noticed strange discrepancies in galaxy clusters. Certain regions seemed to warp the light of distant stars, bending it as if enormous masses were present, yet telescopes revealed nothing but empty space. The culprit, dark matter, the mysterious substance that makes up 85% of the universe's mass. In most galaxies, this invisible scaffold is laced with stars and gas, but in dark galaxies, it stands nearly alone, a skeletal framework without the flesh of starlight. So how do you find something that barely emits any light? One method relies on gravitational lensing, the way massive objects bend space-time, distorting the images of galaxies behind them. When a patch of seemingly empty space distorts light like a funhouse mirror, it's a telltale sign of unseen mass. Another clue comes from rogue clouds of hydrogen gas drifting without stars to illuminate them. Using radio telescopes, astronomers have detected these ghostly reservoirs, their faint emissions betraying the presence of a galaxy that never fully formed. But the real mystery isn't just their darkness, it's why these galaxies failed to spark. One theory suggests they're cosmic stillbirths, regions where gas was too sparse or too hot to collapse into stars. Another posits that supernova explosions or black hole activity in their youth blew away their star-forming material, leaving behind barren husks. Then there's the eerie possibility that some dark galaxies are the remnants of ancient collisions, their stars stripped away by violent encounters, leaving only their dark matter skeletons behind. Yet these ghosts might hold the key to one of astronomy's biggest puzzles, the missing satellite problem. Simulations predict that thousands of small galaxies should orbit large ones like the Milky Way, but we've only found a fraction of them. Dark galaxies could be the missing pieces hiding in plain sight, their starless forms invisible to conventional surveys. If so, the universe might be teeming with these shadowy realms, far more numerous than the glittering galaxies we know. The discovery of Dragonfly 44 in 2016 brought the Enigma into sharp focus. Lurking in the Coma cluster, this galaxy weighs as much as the Milky Way but emits less than 1% of its light. Follow-up observations revealed its 99.9% dark matter, a floating halo of the unknown with only a scant sprinkling of stars to hint at its presence. What makes these phantoms so unnerving is what they imply about the cosmos. If galaxies can exist without stars, what else are we missing? Could there be entirely dark constellations, black hole archipelagos, or even rogue planets drifting unseen? The more we search, the clearer it becomes. The universe isn't just stranger than we imagine, it's stranger than we can imagine. And somewhere in that darkness, the ghosts are waiting, silent and vast, daring us to find them. At the heart of the constellation Gemini, an astronomical paradox lurks. LB1, a black hole so massive it shouldn't exist. Discovered in 2019, this cosmic heavyweight clocks in at a staggering 70 times the mass of our Sun, shattering the accepted limits of stellar black holes. According to everything we know about star death, Black holes this large simply can't form from a single collapsing star, and yet there it sits, defying textbooks and sending researchers scrambling for explanations. The problem lies in stellar physics. When massive stars exhaust their nuclear fuel, they explode as supernova, leaving behind either a neutron star or a black hole. But there's a catch. The violent energy of these explosions should blow away so much material that the remaining core couldn't possibly collapse into a black hole beyond 40 or 50 solar masses. LB1 bulldozes right through this limit, forcing scientists to confront an unsettling possibility. Either our models of stellar death are fundamentally flawed, or this black hole formed through some exotic process we've never witnessed. Cue the controversy. Skeptics immediately question the measurements, suggesting the black hole might only appear massive due to an optical illusion, perhaps a binary system mimicking a single object. Others speculated that LB1's companion star, a bright B-type star orbiting it every 79 days, might be distorting the data, but follow-up observations only deepened the mystery. The team used multiple methods, from radial velocity measurements to spectral analysis, and the numbers kept pointing to the same impossible conclusion. This black hole was real, and it was breaking all the rules. So how did LB1 cheat the cosmic weight limit? One radical theory suggests it's a second-generation black hole, formed when two smaller black holes merged inside a dense star cluster, their combined mass creating this celestial outlaw. Another idea points to fallback supernova, where a dying star's explosion falters, dumping extra material back onto the nascent black hole like a cosmic buffet. The most tantalizing possibility, that LB1 was born from a dark star, a hypothetical primordial giant made mostly of dark matter that collapsed directly into a black hole without a traditional supernova. The debate rages on, but one thing's certain: LB1 isn't just a curiosity, it's a wake-up call. If black holes this massive can form naturally, it means the universe might be teeming with similar monsters lurking unseen in the darkness. Future gravitational wave detectors could hold the key, listening for the ripples of collisions between these forbidden giants. Until then, LB1 remains a cosmic rebel, challenging us to rethink how stars live, die, and sometimes defy the odds in ways we never saw coming. Picture a world untethered, a planet wandering alone through the infinite black, no star to warm its surface, no sunrise or sunset to mark the passage of time. These are rogue planets, the nomads of the cosmos, drifting through interstellar space like cosmic outcasts. Astronomers estimate there could be billions of them in the Milky Way alone, outnumbering stars by a staggering margin, yet they're so dark, so isolated, that finding them is like spotting a single candle flickering in a desert at midnight. How does a planet end up orphaned? Some are born that way, condensing from tiny, cold clouds of gas and dust too sparse to ignite into stars, a process eerily similar to stellar formation, but on a smaller, darker scale. Others start life in ordinary solar systems, only to be violently ejected by gravitational chaos. Imagine a young system where planets jostle for position, their orbits unstable. One wrong interaction, a nudge from a passing star, or a tug of war between gas giants, and suddenly a planet is flung into the void, doomed to wander forever. But here's the twist: these lonely worlds might not be barren wastelands. Cut off from the warmth of a sun, you'd expect them to freeze solid, and many do, their surfaces plunging hundreds of degrees below zero. Yet beneath icy crusts, tidal forces or radioactive decay could maintain vast subsurface oceans, liquid water trapped under miles of ice. On Earth, we've found life thriving in the most hostile places: volcanic vents, Antarctic lakes buried under glaciers. Could rogue planets harbor similar extremophiles, their ecosystems powered by geothermal vents or chemical reactions we've yet to imagine? The possibilities get stranger. Some rogue planets might even have thick hydrogen atmospheres, acting like insulating blankets to trap heat from their formation. Others, kicked away in their system's youth, could retain primordial hydrogen-helium envelopes, creating pressures so intense that exotic forms of ice hot enough to melt but compressed into solid states form layered mantles. Picture an ocean not of liquid water but of superionic ice, a bizarre phase where water molecules break apart, yet the oxygen crystallizes while hydrogen ions flow like a conductive fluid. Then there's the haunting question of detection. Rogue planets emit no light, and their faint infrared signatures left over heat from their birth are drowned out by the galaxy's background glow. To find them, astronomers rely on microlensing, a cosmic quirk where the planet's gravity bends the light of a distant star like a magnifying glass, briefly brightening it. But these events last mere hours, leaving little time to study the interloper. Recent discoveries hint at how bizarre these worlds can be. In 2020, astronomers spotted a rogue planet roughly the size of Earth floating freely in the Milky Way's bulge. Then came the real stunner, a Jupiter-sized rogue with auroras, its powerful magnetic field generating shimmering light shows in an otherwise starless sky. If a planet with no star can have auroras, what other surprises might these drifters hold? The more we learn, the clearer it becomes. Rogue planets aren't just cosmic oddities. They could be silent arcs carrying the ingredients for life across the galaxy, or perhaps dark incubators where chemistry experiments unfold in perpetual night. Either way, they force us to rethink what makes a planet alive, and whether the universe's greatest biospheres might be hiding where we least expect them, in the endless dark between the stars. For decades, astronomers faced a cosmic accounting problem. The universe's books didn't balance. When they tallied up all the ordinary matter, the protons, neutrons, and electrons making up planets, stars, and galaxies, nearly half of it was missing. This wasn't dark matter, that enigmatic substance we can't see, but the very stuff we're made of seemingly vanished without a trace. These lost baryons became one of astrophysics' most persistent puzzles until scientists realized the answer might be hiding in plain sight, woven into the fabric of the cosmos itself. The breakthrough came when researchers turned their attention to the cosmic web, the vast network of filaments that connect galaxies like threads in a spider's silk. This structure, spanning billions of light-years, is the scaffolding of the universe where dark matter's gravity funnels gas into rivers of hot plasma. Simulations had long predicted that these intergalactic highways should contain most of the universe's ordinary matter, but spotting it was like trying to see steam rising from a kettle in a foggy room. The gas is so diffuse, so blisteringly hot, it emits almost no light, leaving it invisible to traditional telescopes. Then came the game changer, indirect detection methods. By studying how light from distant quasars, the brilliant cores of active galaxies filtered through these filaments, astronomers detected the fingerprints of ionized oxygen. Like tracing the outline of a shadow, these absorption lines revealed the presence of gas so hot it stripped electrons from atoms, forming a plasma soup with temperatures reaching millions of degrees. Suddenly, the missing baryons had a hiding place. They weren't gone, just masquerading as an ultra-thin, ultra-hot fog stretching between galaxies. But the mystery didn't end there. Even with this discovery, some of the predicted matter remains unaccounted for, tucked away in even more elusive forms. Some might lurk in the WIM, the warm hot intergalactic medium, a theorized realm of moderately heated gas too cool to glow in X-rays but too warm to absorb much light. Others could be trapped in galactic winds, vast outflows ejected by supernova and black holes, scattering atoms across intergalactic space like cosmic confetti. The implications ripple far beyond bookkeeping. These hidden reservoirs might hold clues to how galaxies form and evolve, acting as both fuel stations and dumping grounds for star-forming material. They could explain why some galaxies stop forming stars, their gas supply literally floating away into the void, and they force us to rethink the universe's structure, not as islands of matter in an empty sea, but as knots in a shimmering net where most of reality's stuff flows unseen in the spaces between. As telescopes grow more sensitive and simulations more refined, we're peeling back another layer of the cosmic onion, realizing that what we once called empty space is anything but. The missing baryons were never truly lost, just waiting for us to learn how to see them. And in that lesson lies a humbling truth. Sometimes the universe's biggest secrets aren't hidden in the distant unknown, but in the overlooked spaces right in front of us. If the universe's accelerating expansion feels unsettling, brace yourself for an even more extreme possibility: phantom energy, a hypothetical form of dark energy so destructive it could tear reality itself apart. Unlike the cosmological constant Einstein's static vacuum energy that drives our current expansion, phantom energy grows stronger over time, its density increasing as space stretches. Think of it like a runaway engine. The more the universe expands, the more power phantom energy gains, creating a feedback loop with apocalyptic consequences. The cosmological constant, often represented by lambda in equations, acts like a gentle pressure permeating empty space, pushing galaxies apart at an ever-increasing but steady rate. It's the universe's default setting in modern physics, neatly matching observations of supernova and cosmic microwave background radiation, but phantom energy. It's lambda's volatile cousin. Instead of maintaining a constant density, its repulsive force escalates exponentially, meaning each passing moment makes the next burst of expansion even more violent. If this exists, the universe wouldn't just expand, it would self-destruct. Here's where the nightmare scenario unfolds. In a phantom energy-dominated cosmos, the acceleration would eventually overcome every fundamental force. First, galaxy clusters would be ripped apart, their gravitational bonds no match for the escalating push. Then individual galaxies would unravel, stars torn from their orbits like leaves in a hurricane. Next, planetary systems would disintegrate. Finally, in a cataclysm dubbed the Big Rip, even atoms would be shredded apart, protons and electrons separated by the unstoppable stretching of spacetime itself. The end wouldn't come with a collapse or a freeze, but with a literal disintegration of matter. Why consider something so extreme? Because dark energy remains one of physics' greatest enigmas. The cosmological constant fits current data beautifully, but it raises its own paradoxes, like why its observed value is shockingly tiny compared to theoretical predictions. Phantom energy offers an alternative, one that could explain certain anomalies in large-scale structure observations. Some models even suggest it might reconcile discrepancies in measurements of the Hubble constant, the rate of cosmic expansion. Yet the evidence remains elusive. No direct observations confirm phantom energy's existence, and many physicists consider it a speculative outlier, but its implications are too profound to ignore. If real, it would imply a future where the universe doesn't just fade into cold darkness, it violently unravels. That tension between the known and the possible is what makes phantom energy so haunting. It's a reminder that our understanding of cosmic fate is still written in pencil, not ink, and the universe might have horrors in store we haven't even begun to fathom. From rogue planets drifting in eternal night to phantom energy threatening cosmic annihilation, we've journeyed through 30 of the universe's most bewildering wonders, each one a testament to the fact that reality is stranger than fiction. The cosmos doesn't just defy our expectations, it laughs at them, serving up enigmas that humble even the sharpest scientific minds. Who could have imagined a star older than the universe itself, or a black hole so massive it breaks the rules of stellar demise? These aren't just curiosities, they're cosmic breadcrumbs, clues that the story of existence is far wilder than we've dared to dream. Think about the implications. Every mystery we've explored, the great attractor's gravitational pull, Oumuamua's impossible acceleration, the cold spot's eerie chill, is a reminder that we've barely scratched the surface. For every question answered, a dozen more emerge, whispering of forces and phenomena we haven't even named yet. The universe isn't just vast, it's layered, hiding puzzles within puzzles, from the quantum foam of spacetime to the unfathomable voids between galactic superclusters. And here's the thrilling part: this is your era of discovery. With telescopes like James Webb peering deeper than ever and gravitational wave detectors listening to the ripples of colliding black holes, we're on the brink of revelations that could rewrite textbooks. Maybe you'll be the one to crack the code of fast radio bursts or spot the next interstellar visitor tumbling through our solar system. The universe isn't done surprising us, and neither are we done exploring it. So, which of these cosmic oddities left you spellbound? Was it the diamond planet, a world literally made of gemstones, or the zombie star that cheated death? Drop your favorites in the comments. I'd love to hear which mysteries keep you up at night. And if you're hungry for more deep dives into the universe's strangest corners, don't forget to hit subscribe. The cosmos has endless stories to tell, and together we'll keep unraveling them, one mind-bending discovery at a time. Until next time, keep looking up, because out there in the infinite dark, wonders beyond imagination